Okay, in this video, I want to start talking about compound inequalities. Here we have an example of a compound inequality where x is between two numbers. You have 18 is less than or equal to x is less than or equal to 21. And I drew the graph here, and you can see that x is literally in between 18 and 21. I wanted to include 18, so the dot is filled in. I want to include 21, so the dot's filled in. And I want all the numbers in between. In interval notation, I want to include 18, so I have a bracket here. I'm going to 21 and bracket again. So this is 18 to 21, including 18 and 21. For set builder notation, most of the work is already done because the inequality is already solved. So I can write this as braces x such that, 18 less than x less than or equal to 21. So this is how we could write that same information in set builder notation. Again, we're just writing the solved inequality in set builder notation, and this is now a list of all the values that are correct for x. All right, let's look at another example. In this example, we have a graph, and it's from -4 to infinity, and we're starting at -4, but we want to include -4. And because of that, well, how are we going to write that inequality? So I want x greater than -4, and since I want to include -4, it's greater than or equal to -4. Okay, so if I make this in set builder notation, it should be x such that x is greater than or equal to -4, and I just need to draw my braces around it. So that's how I can do set builder notation. Interval notation, again, we're starting at -4 and we're going to infinity. So I want to include -4, and I'll never actually reach infinity, so it's braces. And so this is how you would write the answer in interval notation, and this is how you would write it in set builder notation. Okay? Let's look at another compound inequality. I have 10 is less than 5x is less than 65. And I need to get it where it's just x and not 5x. So I'll divide both sides by 5. Okay. And what's that going to become? 2 is less than x is less than 13. And now I'm ready to answer the question. So in set builder notation, I can just rewrite that information. 2 less than x less than 13. Okay. In set builder notation, well, I'm going to draw the picture and show that it's 2 and 13. I don't want to include 2 and I don't want to include 13, so I put holes in between those, and then I want all the numbers in between. So it's from 2 to 13, not including 2 and 13. Okay, and that's it. That's how you can answer those questions. So that's how you'd answer it in interval notation. That's how you'd answer it in set builder notation. And this is how you would draw a graph of it. The next thing I want to talk about is and versus or, which is always very confusing to students when they first deal with this. If you take finite, you're going to deal with it a whole lot. Okay, so I want to break it down as clearly as I possibly can. And this is in mathematics, and versus or. So if I asked you to get me a coffee and a cookie, okay, then I want both. Both have to be present. If, let's say, the cafe didn't have a cookie, then it's nothing. It's both, and I hate to use the word or, so I'm just going to use comma, nothing, okay? So it's not how we use it in everyday language. Generally, if someone asked you, can you get me a coffee and a cookie? If they ran out of cookies, chances are you would still get that person a coffee. But in math, it has to be both or nothing, okay? If they don't have coffee, I don't want a cookie. I don't want anything, all right? However, or in mathematics, or in logic as well, or is both, one, or nothing. So it can be both coffee or cookie. So if they have coffee or cookie, you can have both. You can have one or you can have nothing if nothing fits what we're looking for. Okay, so that's confusing because that's not how we use or in everyday language. We don't use coffee or a cookie. Generally, if you asked me to get you something like that, I would just get you one of those things. But in mathematics, it's both if that's possible, it's one if that's possible, or it's nothing if they don't have either of those things. However, and it has to be both or nothing at all. Okay? That's kind of confusing because that's not how we use it in everyday language, but that is how it's used in logic. It's how it's used in mathematics. It's how it's used in programming, computer programming. So we have to just get used to that idea. Okay, so let's look at an example with some numbers, and we can see how this works. We have two inequalities. I'm going to solve both of them, and I'm going to describe what this and does to it. So first, I'll subtract 5 on both sides. So I have 2x is less than 14. Divide by 2, divide by 2. I have x is less than 7. Okay, I'll just leave that alone for a second and solve this one. Plus 3, x is greater than or equal to 3. Okay, and it's and, so I have to understand what that means. Now, if I draw a picture, I'm interested in 3, so I'll draw it here. I'm interested in 7. I'll draw it there. Looks like I want to include 3, and I don't want to include 7. Okay. Now, I want the numbers that are greater than or equal to 3. Maybe I'll do this in a different color. So numbers that are greater than equal to 3. So those are going to be these numbers. Okay. And numbers that are less than 7. So I'll do that in a different color. Less than 7, not including 7, would be these numbers. Now for the and, I have to determine what numbers work for both of those statements. Again, that would be the numbers that are highlighted twice, the way I've done it here. The numbers that are highlighted twice are 3 to 7, okay? Not including 7. Those were the numbers I highlighted twice. So in interval notation, which is usually the easiest for students to understand, would be 3 to 7, not including 7. That would be the numbers that would satisfy both of them, okay? Now, if I want, this is the same problem again, I just wrote it again. The only thing that's different is the word or. And so I want to show you what the answer would be is if I just changed the word from and to or, would it change the answer? In fact, it does. What's going to happen is anything that's highlighted at all for or will be included. And so that is going from negative infinity to positive infinity, okay? I can't include either of those because they'll never actually reach infinity, but here, anything that's highlighted, that's what or stands for. And that's what I was on about with the both. So if I can, I'm going to do both, and I could. So anything that was highlighted in this will satisfy the or, but only things that were highlighted for both of them can satisfy the and. You will have problems where nothing works, and so the answer would be like no solution, okay? So that's confusing, and I anticipate some people asking me questions, so don't hesitate to do that. But this should at least give you a start of thinking about the difference of and or. Okay, I'll see you in the next video where we're going to talk about inequalities with absolute values, but please reach out if you have any questions about any of the material covered. All right, see you in the next video.